Let's look at section 6.6. Section 6.6, we're going to be solving quadratic equations by factoring. Now, right now, the only way we're going to solve quadratic equations is by factoring. But we do have 0310 coming up. And there we're going to talk about how we can solve them not just by factoring, but by other methods. But first, you know what a quadratic equation even looks like. A quadratic equation is of this form. ax squared plus bx plus c equals 0. See, we had this form before, but we didn't have it equal to anything. We just had this guy. Okay, that guy is a quadratic. It's our normal basic trinomial that we've worked with. We know how to factor. Now when I set it equal to 0, I've created an equation, which means the results are going to look a little bit different. The results for solving, or the results for an equation means you're going to solve, you're going to have a solution, right? Everything we've done up to this point has just been factoring. So now we're going to combine our factoring skills with solving equations, and we do that with something called the zero factor theorem. Now, the zero factor theorem tells you exactly how you go about solving these problems. We're going to go over that here in just a moment. But first, the zero factor theorem states the following. If you have a product a times b that equals 0, then what can you conclude? If you multiply to get 0, what do you know? Say again?
Multiply times 0.
That means one of these guys has to be 0, right?
Right.
Okay. So you agree that I can say that that means a equals 0, b equals 0, or both of these guys are 0, right? Do y'all agree with that?
Yes.
The only way to have 0 as a product is if one of your factors is 0. That is a guarantee. Now notice I'm calling this the zero factor theorem. There is no other number here that has its own factor theorem. There is no two factor theorem. If I said two numbers multiplied to equal 2, what are the numbers? Do you know?
1, 2.
Nope, that's not what I had in my head. You're wrong.
Say again. What's the question?
Two numbers that multiply to give you 2.
Multiply to get you 2?
Yep, he said 1 times 2.
2 times 1.
Nope. Well, it's a product. Who cares what order they're in? I was actually thinking of 1/5 and 10. 1/5 and 10. That's what we were going for. So is there a guarantee when you're multiplying to equal 2? There's no guarantee. Is there a guarantee when you multiply to equal 0?
Mm-hmm.
You are guaranteed that somebody is 0. You with me on that?
Mm-hmm.
That's why it's important that we have the zero factor theorem. We have multiplication equal to 0. So let's start off with this example. If I ask you to solve x plus 4 times x minus 9 is equal to 0. The zero factor theorem tells you the steps you take to solve these guys. The first step is that you have to have everything on one side and 0 on the other. It has to equal 0. The second step is to factor. And then the third step is just using the theorem itself. I'm going to show you how that theorem applies in the example we have right now. Notice in this example, I already had this equal to 0. Yes? And isn't this guy already factored? So we're saying that x plus 4 times x minus 9 equals 0. According to the zero factor theorem, that means that the factor x plus 4 is equal to 0, or what?
Minus 9.
Or the other factor, x minus 9 equals 0. That's what it's saying. Now, if I gave you just this guy right here, x plus 4 equals 0, this is an equation, and in equations we want to get the variables by itself.
Mm-hmm. So we're going to do it again.
How do I get x by itself?
Minus 4.
You subtract 4 So that means that x equals what?
4, 0. -4.
Negative 4. Now, is this a true statement? Does x equal negative 4?
Mhm.
How do we know that?
Because we moved it to the other side.
Because we go check it, -4 plus +4 equals 0.
Negative 4 plus positive 4 is 0, right? If I plug negative 4 in here, what do I get?
-13.
So what's 0 times negative 13?
0.
So this guy checks out. What about this guy over here, though? If x minus 9 equals 0, do the mental math, that means that x must equal what?
Positive 9.
Is that guy, does that guy work out? If I plug 9 in here, what do you get?
13.
13. If I plug 9 in here, what do you get?
0.
What's 13 times 0? So that guy also gives me a true statement, right? So that tells me that I have two possible answers here for this equation. My solutions are x equals negative 4 or x equals 9. Because you saw that when I checked either one of those, it would work out. So that opens up this huge door of possibilities for us. Because normally when I solved equations back in the first week of class, how many solutions would I have? One. Now I can have more than one solution. Can I get an oh ye?
Oh, yeah. I tried.
We gotta work on getting you some street cred. Oh yeah. No, it's oh ye. Let's try this example and let's see what you guys can do here. X squared minus 15x plus 50 is equal to 0. Now, if I want to use the zero factor theorem, the first rule, the first step is to have everything equal to 0. Do I have that?
No. Yes.
Yeah, this equals 0,
Yeah.
right? The second word says factor. Is this factored?
No.
So then you factor it. But of course, at this stage in the game, you already know how to factor because that's what we've been doing the past few days. So how does this guy factor?
X plus 10
No.
was
Number 1, you look for a greatest common factor, but there's not one other than 1. Number 2, you have 3 terms, so it should factor as 2 binomials.
10 and 5.
X.
Watch your signs. You have to multiply to get a positive 50, but you need to get a negative when you add those guys, so you need 2 negatives. And what are the numbers?
5 and 10. X minus 5. Or 10 and 5.
So 10 and 5, 5 and 10, it doesn't matter, does it?
No.
Okay. So that means, since this is factored and equal to 0, I can use that zero factor theorem. So that means that x minus 10 is equal to 0, or what?
X minus 5.
Or the factor x minus 5 is equal to 0. So here this means that x equals what?
10.
10, or x equals what?
5.
Or x equals 5. Now we shouldn't have any issues checking these guys into the original equation, and you'll see they both work out. The thing is, when you check them one at a time. Okay? If I plug in 10, I get 100 minus 150 plus 50, and that would give me 0. So if you plug that in there, you'd have 100 minus 150 plus 50, that does equal 0.
How'd you get 150 again? I'm sorry.
15 times 10. If I plug in 5, I get 5 squared, which is 25, minus 15 times 5 is 75, plus the constant 50 that was already there. Does that equal 0? Yes. So it's pretty easy to check that both of those guys do work out and are true in my original equation.